Hello, ladies and gentlemen. This is Mr. Green, and this is another recording in the series of recordings on Algebra 2. We are starting another new unit this week, and we probably will get through most of this unit this week. So hang on, buckle up. It's going to be a fast one, okay? So let's look at what we're doing. We're doing Unit 5. This is work with polynomials. A lot of this work is repeat of stuff that you've done in Algebra 1, or hopefully you did in Algebra 1. And we'll see how far we get on this before we have to turn around and do some other things, okay? First of all, polynomials and the power function. Remember, when we're looking at a polynomial, it is anything you find the degree, excuse me, you find the degree, the leading coefficient, and the constant term of a polynomial, and write a polynomial expression in standard form. You always start with the highest degree and go to the lowest degree. Okay? Um, and you can classify polynomials by their degree or by the number of terms that they have. So what we're going to be doing is adding and subtracting and simplifying polynomial expressions. Just a note, anytime I raise anything to the 0th power, it's always 1. It doesn't matter what it is. If it's raised to the 0th power, it's 1. That's the answer for that one, 1. Don't have to think about anything else. It's 1. So 3a squared raised to the 0th power, 1. That's all you got to remember. It's really quite a simple process there. It's always going to be 1. So let's look at some of these and see what we have. If I'm raising something to the 3rd power, it's read 5 to the 3rd power here. And 5 is the base and 3 is the exponent. And if we're going to raise it to the 3rd power, that means that we're taking 5 times 5 times 5, and that's equal to 125. Okay? Not a problem. We can do these without any problem. Let's try some of them here. 8 raised to the 4th power. That is 4096. 4096. Okay? If I'm raising something like 2/3 to the 2nd power, I'm going to raise the 2 to the 2nd power, which is a 4, and a 3 to the 2nd power, which is a 9. I raised both parts of the fraction to the 2nd power. Here I'm raising this all to the 1st power. 2abc to the 1st power. Well, guess what? To the 1st power just means multiply it times itself once, so that would be 2abc. Here I'm taking negative 7 to the 2nd power, or squaring it. That's 49. And 625 plus 275, that's 8. 9 raised to the 0th power, that's 1. Always 1 because I'm raising to the 0th power. Now, just a word about calculators. Calculators can be your friend, okay? And I want to show you something with the calculator just so if you haven't seen this already or didn't know this, you would know it. I'm going to show you how to raise 8 to the 4th power. This little caret button over here, up arrow, 4, press enter, and it will raise it to the 4th power. If you want to raise 2/3 to the 2nd power, 2 divided by 3. You notice how I put the fraction in the parentheses? I can press the squared button, or I can raise it to the 2nd power and hit enter, and it will figure it out. Now, it did put it in a decimal form. I can always press math and have it express it as a fraction, and it will express it as a fraction for me. Okay? Negative 7. You always put parentheses around negative signs. Negative 7, parenthesis, and you're raising that to the 2nd power, 2. You press enter, and it gives you the 49. Okay? Okay, enough of that. I just wanted to make certain you knew a little bit about the calculator and knew how to work those type of things. There is a property rule that says when we're multiplying products, multiplying things together that have exponents, as long as the bases are the same, all you got to do is add the exponents. So, negative 4, I'm sorry, 4 plus negative 3 would give you a 1, and I would have 4 to the 1st power, which is equal to 4. Y times y to the third times y to the fourth. I'm just going to add them. This is a 1. 1 and negative 3 is a negative 2, plus 4 is a 2. So this is going to be equal to y squared. Okay? So if I've got negative 2 to the third, negative 2 squared, that's going to be equal to negative 2 to the fifth power. I'm adding them across. That's all I'm doing. Now I've got d to the negative 3 and d squared there. I'm going to add those together and get d to the negative 1. And then I've got f to the fourth and f to the 0. I'm going to add those together and get f to the fourth. Here I've got x, y, and z. I have nothing common there. And so this is going to be equal to x, y squared, z cubed. Does everyone see how I'm using that rule? I hope. If you don't see it, come to Toga. We'll talk about it. Okay? I don't want to work all of these, but I do want to show you how these exponent rule works when we're doing things that are inside of a parenthesis raised to a power. Instead of adding, we're going to multiply. So right here I've got 5y times x squared y to the sixth. Well, since these are going to be multiplied together, it's going to be 5y to the seventh x squared. I'm simply taking this exponent and making certain it applies to both of the terms that are in here. So the x squared goes on the x squared times the 3 gave me 6, and I added the 6 and the 1 and got 7. Okay? Here I'm going to do this one. 1/2. 2 cubed is 8, and a cubed is a cubed. Cubed to the third power. And when I multiply 8 times 1/2, I get 4a cubed. Here I've got 2s times 6 times 2 is 12. That'd be s to the 12th times t to the 6th. Well, 12 and 1 will be 13, so this will be 2s to the 13th t to the 6th. Okay? Like I said, I don't want to do all of these, but I did want to show you how they're being done. Okay? Okay. Interesting one down here. I just saw it. Let me do this one right here. I've got 4 to the first and 4 to the second inside of parentheses. I'm going to do that first, and that's going to give me a 4 to the negative first. And I'm cubing that. This will be 4 to the negative 3. By the way, what does the negative sign mean? That means it's 1 over 4 to the third. That's what that means. Right here. Okay? Well, 4 times 4 is 16 times 4 is 64. So this would be 1 over 64. That's what the negative sign means. If I wanted to take the square root, I'd use fractions, 1/2. Okay? So let's moving on. What we're going to be looking at here is trying to get some definitions down. And one of the definitions I want to make certain you know is a monomial. A monomial is a number, a variable, or a product of a number and one or more variables. And it can have variables with whole numbers, exponents. It can have any number of exponents on it, or any number of variables all multiplied together. It's still called a monomial. Okay? Monomials are sometimes called terms in polynomials. Okay? So if you're seeing multiple things put together, those would be a polynomial. And if you're looking at just one term, it's a monomial. So looking at the issues down here at the bottom, this is a polynomial. It actually has P-O-L-Y, polynomial. It has 3 terms. It's got this term, it's got this term, and it's got this term. 3 terms. This one is a polynomial. It has 3 terms. This term, and this term. Okay? You see how that's working? Now, poly simply means many. There are some definitions that we can use there. If we combine like terms together, we sometimes can reduce the number of things that we have. But anytime that we have variables raised to the same power, those are considered like terms. And you can add their coefficients together then. The degree of a monomial is the sum of all the exponents of its variable factor. So if I've got a cubed s to the third, I would add the 2 and the 3 and get a 5 and say, that has a degree of 5. The degree of a polynomial is the degree of the monomial with the highest degree, or the greatest degree. Okay? A polynomial can be simplified when there are no more terms that are exactly the same than it's considered to be in its simplest form. So, let's look here. Oh, one more thing. The leading coefficient in a polynomial in simplified form is the coefficient of the first term. Okay? Okay. Looking at this problem right here, what do we got? We're trying to simplify this. First thing I'm going to look at, I'm going to look for the highest degree. It happens to be to the third. I see only one other thing that's to the third here. And I'm going to take and combine those together. I've got plus 2x and minus 5x cubed. That's going to give me a minus 3x cubed. And then I'm looking here at my x squared term. And that's going to be minus 6x squared. Then I go to my x terms. And I've got a 9x and an 8x at 17. 17x. And then I've got a constant term, and I got a 2. I'm looking for the ones that are the like ones, the ones that are the same. It's called combining like terms. And when I combine them together, it's when we're making this get to simplified form. This would be the simplified form in standard form of this polynomial. So what's the degree of this polynomial? The degree of this polynomial is a 3 because it's to the third power. How many terms are there in this polynomial? There are 4 terms in this polynomial. Okay? You guys see where I'm getting that from? 1, 2, 3, and 4. 4 monomials combined together, adding or subtracting. So let's move forward here. A monomial has one term. It could be as difficult as a cubed b squared d to the fourth over 64. That's still a monomial. I'm not adding anything together in there. A binomial has 2 terms. A cubed b squared plus c to the third d to the fifth. That would be a binomial because I've got 2 things being added together. That's where you see the difference there. A trinomial has 3 things being added together. 6a cubed plus 7b squared minus 17. Trinomial. Okay? It's just a matter of how many terms they have. Monomial, binomial, trinomial. Okay? Now, if we're looking at their degree, if it's a constant, the degree is 0. If it's linear, the degree is 1. Why am I saying that? Because this is x to the first power. And this is x to the 0th power. Remember, x to the 0 is 1. 1 times negative 7 gives me negative 7. That's where we're getting it from. This one has a degree of 2. It's called a quadratic equation. It has 2. If you see a degree of 3, that puts it at a cubic equation. 4 quatric, 5 quintric, and the nth degree would be something raised to the nth power. Nth degree. That's how that works. So let's look up here. What degree is this one up here? Well, 3 plus 2 is 5 plus 4 is 9. This is to the degree 9. How about this one? I've got a 5 in this side and I've got an 8 over here, so this is degree 8. How about this one? This is a degree 3. Okay? So here I've got a monomial that's of higher degree than a binomial that's of higher degree than a trinomial. Okay? Just because they're trinomials doesn't mean they're bigger than the monomials. Monomials could be much bigger as far as degree is concerned. So you just have to be able to recognize how to classify those things. Okay? Okay, let's look at these. Do these make polynomials? Well, this right here is going to wind up to be 3 divided by z cubed. That would typically disqualify it as a polynomial because we've got a variable in the denominator. Okay? And it would most likely disqualify it as a polynomial. Okay, this one, 25x square root of x to the third power x. This one will be a polynomial, even though it's got that square root in it. Yeah, square root is 1/2, so what we're doing there is saying x to the 3 over 2. That's not a negative number, that's a positive number. That one would qualify as a polynomial. Okay? So let's look at this one. This is a binomial, degree 1. This one down here is a trinomial, degree 5. Okay? Look down here at the bottom. It says find the degree in the leading coefficient and the constant term. Well, looking through here, I see something to the third power. Nothing. Oh, there's a to the fourth power. Okay? That means my degree is 4. And my leading coefficient is going to be a negative 4. Where did I get the negative from? Right here. Negative 4. Okay? What would my constant term be? Well, I see a 5 sitting here. I don't see any other constants on there. My constant is going to be a 5. Okay. Can this one be simplified? Yeah, the 14 and the 7 can be combined together, and I would get 3z minus 7. How about this one here? I got an x squared term in both twice in here, so that'd be 12x squared plus 16x minus 2. Why did I write it like this? Because standard form, I'm writing the x's in descending order, or writing the z's in descending order. Okay? So, looking at this equation up here, it says find the like terms. Well, I see a c cubed and a 25c cubed. So that's going to be 26c cubed. I see a d, a 6, and a 1/4 d. That's going to give me 6 1/4 d. I see a p to the third 7, and a p to the third 2, and a p to the third minus 1. That's going to give me an 8 p to the third. But I don't see anything with that p squared, so that'd be a 14p squared. Do you see how I circled them so I didn't have to count them again? That's the way you find like terms. How do I add and subtract polynomials? The biggest thing to remember here is if I'm subtracting them, this is like adding a negative 1, and that negative 1 then has to be distributed to each of these terms. So this becomes z minus 3z squared plus 4 plus negative 4 plus 3z. Because that's negative 3z times negative 1 gives me a plus 3z. So then writing it in standard form would be a minus 3z squared. I'm going to put that on there. And then I've got plus 4z minus 4. Okay? Down here, I've got a plus sign. I don't have to do anything like that. So I'm going to combine my x cubed terms. I got a minus 3x and a plus x, minus 3x cubed and a plus x cubed. That's going to be a minus 2x cubed. Okay? I've got a 5x and a minus 3x. That's going to be plus 2x. And I've got a 9 and a minus 4. That's going to be minus 5. Okay. Once again, minus sign. That means this is going to be a negative. That one's going to be a negative. That one's going to be a negative. So I'm going to add the like terms together. I've got 3/4 x cubed and minus 4x cubed. That's minus 3 1/4 x cubed. Okay. I've got a 2x squared. So that's a minus 2x squared. I've got a 2x. And I've got a minus 6 and a minus 3. That's minus 9. Okay? I'll leave this one for you to work. Let me know what you get. Okay? What I'm telling you guys is these adding and subtracting polynomials is difficult, but it's something you should have been used to doing from Algebra 1. If you have any questions, please come to Toga. I want to help you guys. I'm in Toga on Monday through Thursday from 3 to 5. I'm also there on Fridays from 11 to 12. You can come in, ask questions, and I will help you with it. Okay? I will see you next time I see you.